Hey everyone, and welcome to The Explainer. Today we're getting into the mind of a man whose work literally mapped the course of human history. We are talking about Claudius Ptolemy. Living between 90 and 170 AD, he was this brilliant Greco-Roman mathematician, astronomer, and geographer working out of the great library in Alexandria. Now, to truly understand Ptolemy, you have to realize he represents the absolute climax of classical antiquity. He basically finalized the geographic and mathematical traditions that had been kicked off centuries earlier by thinkers like Thales and Eratosthenes. And in doing so, he built the foundation for how humanity viewed the globe for centuries. So here's our roadmap for today's explainer. We'll start with how he redefined cartography, then look at his geocentric view of the universe, dive into his map-making techniques, explore his surprising physical discoveries, and finally unpack the incredible legacy of his biggest mistakes. All right, Section 1, the master of cartography, defining a new science. Let's set the stage for a guy who is just absolutely obsessed with systematizing the ancient world.
Think about how Ptolemy actually defined his field. He fundamentally called geography a science of the art of map-making. Now, before him, geography was kind of a mess, right? It relied heavily on chaotic, literary descriptions from passing travelers. Ptolemy completely shifted that paradigm. He insisted that mapping had to be based on rigorous mathematical and astronomical principles. His goal wasn't just to write about places. He wanted to totally reform the map of the world based on hard mathematical data.
Moving into Section 2, the geocentric universe, mapping the cosmos. So, before he maps the Earth, he maps the stars. In his highly authoritative mathematical and astronomical treatise, the Almagest, Ptolemy firmly endorsed the geocentric universe, an idea championed by Aristotle and Hipparchus. He asserted the Earth was a stationary sphere sitting dead center in the universe, with the sun and everything else revolving around it. And to explain the sometimes erratic ways planets seem to move in the sky, he proposed these incredibly complex circular motions known as epicycles and deferents to make the math work. And here is the truly wild part about this. The Ptolemaic geocentric model wasn't just a fleeting theory. It became the unquestioned standard reference for classical astronomy all the way until the 17th century. I mean, that is well over a millennium of absolute scientific dominance before Copernicus finally showed up with his heliocentric theory.
Okay, Section 3, the art of mapmaking, the grid and the projection. Let's zoom in from the cosmos down to the globe itself.
So, after the Almagest, Ptolemy drops his second masterpiece, the massive 8-volume guide to geography, or Geographia. Drawing heavily on the work of his teacher, Marinus of Tyre, this was just an absolute marvel of organization. Volume 1 did the heavy lifting, calculating the Earth's dimensions and establishing map projections. Volumes 2 through 7, they were basically the world's first geographical gazetteer, containing exact latitude and longitude tables for over 4,000 places. And then Volume 8 brought it all together with detailed regional maps based directly on those coordinates. But to make a global grid work, you have to anchor it somewhere. Ptolemy adopted the 360-degree grid originally developed by Hipparchus, and then established a prime meridian, a standard north-south line to measure everything else against. He smartly placed this at the westernmost edge of the known world, the Canary Islands, which were known then as the Fortunate Islands. By setting this up, he literally laid down the foundations for modern mathematical cartography. Now, figuring out how to show a curved Earth on a flat piece of parchment is a massive mathematical headache. Ptolemy was so far ahead of his contemporaries here. Initially, he drew the equator as a parallel curve, but kept meridians as straight lines converging at a pole outside the map. He quickly realized, though, that this distorted reality way too much. So he mathematically refined it, curving those meridians so they actually corresponded with the true spherical shape of the globe. Section 4. Mapping the physical world. Surprising accuracies. Let's look at what a second-century scholar actually managed to get right. There are some serious wow moments in his regional geography. For instance, he correctly depicted the Caspian Sea as an inland sea, totally rejecting the old Greek idea that it was an ocean inlet. And he was the first to plot the river Ra, or the Volga, flowing into it. His data on the Nile was amazingly precise. He traced the Blue Nile to Lake Colo, modern-day Lake Tanza, and the White Nile to the Lunar Mountains, likely Kilimanjaro. He was the very first to plot the Bay of Bengal, the Gangetic Gulf, and his map of the British Isles corresponded wonderfully to its actual shape. But of course, the Roman world's knowledge had its limits. For example, he had a pretty good idea of the shape of Taprobane, or modern Sri Lanka,
but he vastly exaggerated its size and shoved it 2 degrees south of the equator. He also thought Scandia, or Scandinavia, was just an ordinary island. But to his credit, Ptolemy handled the edges of his maps with honesty, famously introducing the term terra incognita, unknown land. He acknowledged where the data stopped. Even so, he still made a few wild assumptions, like thinking a giant southern landmass completely closed off the Indian Ocean.
And that brings us to Section 5, Monumental Errors and Legacy, the Flawed Genius. This is where the dramatic irony of our explainer really hits. You see, Ptolemy's undeniable brilliance was paired with some colossal, history-altering miscalculations. Centuries earlier, Aristophanes had calculated a highly accurate measurement of the Earth's circumference. But Ptolemy, he disastrously rejected it. Instead, he went with the calculations of Posidonius, which severely underestimated the size of the globe. And because Ptolemy had to rely on erratic travel times rather than strict astronomical measurements for his longitudes, he ended up vastly overextending the eastern reach of the Asian continent. And this leads to an incredible twist of fate. Ptolemy basically creates a mathematically beautiful map of a much smaller Earth with a massively stretched out Asia. So fast forward to the 1400s and 1500s. Explorers are studying his works, and they look at this map and think, hey, sailing west from Europe to reach Asia isn't actually that far. His massive errors gave them the exact false confidence they needed to spark the Age of Discovery. Which leaves us with this final, really provocative thought. If Ptolemy had actually used Eratosthenes' correct, much larger circumference of the Earth, would Columbus and the explorers of the Age of Discovery have ever dared to set sail? Ptolemy wasn't just an ancient scholar who organized latitudes and longitudes. He was the incredibly brilliant, yet deeply flawed genius who accidentally launched the modern world. Thanks for joining me on this explainer, everyone. Keep exploring, keep questioning the map, and I'll catch you in the next one.